In this part of the lesson we will create a concave pave band, during which we'll be lofting a more complicated ring shank sketch that may require the use of connection lines. So let's create a new part. We're going to be using a basic closed solitaire template, and we'll name our part. Okay, so here we are in our part level, and we'll start off by creating a ring shank sketch. We're going to place this on our 12 o'clock datum plane. So we'll insert a sketch, 12 o'clock datum plane, use centroid defined by plane, confirm the operation. Let's show target to hide our part level. Okay, I'm going to start off by drawing two 2-point lines. I'll give one a horizontal constraint and the other a vertical constraint. Then I'll come in and quick dimension them both. The horizontal line I'll give a length of 12 millimeters, our vertical line 0.5 millimeters. Okay, and we're going to place these on our origin using constraints. Okay, so the first constraint I'll use, using my Smart Constraint tool, I'll pick the curve, endpoint, my origin, I want point coincident constraint, and now I want to constrain the midpoint of this line to here, point to midpoint. Okay, so these two lines we'll be using to define the comfort fit on our ring shank sketch. Okay, so next we'll come in with an arc. Okay, so this is the comfort fit on our ring shank sketch. Let's delete this radial dimension. It's only a reference dimension anyway, so let's delete it. We're going to control the shape of our comfort fit using our two dimensions here. Okay, I'm going to change this to construction geometry. Okay, if you're having a hard time seeing all of your lines and curves, we can deactivate or hide our dimensions, constraints, even our open endpoints. Okay, then we can get a better view. Okay, so here we are controlling our comfort fit. With these dimensions here. Okay, so I'm going to come in and add a few more lines. Let's move our text into a better position. So I'm going to draw 3 more lines. Okay, you can see how it is often easier to draw our lines in free space and then use our constraints to lock them into position. This way we don't get any unwanted auto constraints. Okay, so I'm going to set these all to be construction geometry. I'm control picking them all, right click, construction. And I'll give them some dimensions. This one, 3.5 millimeters. Our other vertical, 0.7 millimeters. Horizontal, 7.5 millimeters. And now I'm going to use my constraint tool to put them into position. I'll first use a point to point constraint. Another point to point constraint. And finally a point to midpoint constraint. Okay, and now I'm going to draw another arc. And I'll delete the radial dimension. Okay, so this is our concave that will have our pave in. And again we have control over the shape of our concave arc from these dimensions here. That are all linked up. Okay, and then I'll come in and finish off or close off this ring shank sketch using the draw tool. I'm going to draw and create a sidewall. I'll bring this length out. I'm avoiding the auto constraints. Okay, you can see the auto constraints being thrown in. I'm avoiding them other than our point coincident constraints and the horizontal and vertical ones. Okay, so here's our sidewall. I'll draw the other side as well. Now let's add in some dimensions. Right click, quick dimension. I'm going to give this sidewall a height of 0.5 millimeters. Okay, and these 2 points are linked up to stay on the same Y coordinate. That's what I want. I'll come in with an angular dimension now. I want to add the angular constraint between these two lines, so I can have control. Let's set it to be about 15 degrees. Do the same for the other side. Again, I'm going to link this up to this value here by using our select dimension. Left click, pick the dimension, confirm. Okay, it's linked up. Like I've said previously, I like to change the color of the dimensions that are linked up to something else so that I know that I don't have to change them. Okay. Finally, we'll add a length constraint to this part of our wall. Right click, quick dimension. Okay, now you can see how there are two types of dimensions we have here. We can sift between them. I want the aligned dimension. Okay, I do not want the horizontal. This is the horizontal. I want the aligned one, this. Sometimes you may have trouble picking between them. You can just select it from here. Okay, so it's aligned. We're going to set this to be 2 millimeters. Again, we'll do the same for the opposite side, but again we will link it up to the other side and change the color. Okay, so we can move our dimensions around to get a clear picture, an uncluttered sketch. This will help when we come back into our designs. Okay, we can check that we have a closed sketch by looking for the little blue squares, which we do not have any of. So this means we have a closed sketch. We can inquire about our sketch, constraint status. Okay, we have a fully well-defined sketch. Okay, so this looks good. I'm going to copy this entire sketch so that we can paste it into our 6 o'clock datum. Okay, so we window pick it all, right click, copy, or we could use the Control C shortcut on the keyboard. Pick the base point, picking it as the origin, confirm the operation. That is now copied to our clipboard. Let's exit our sketch into the part level. I'm now going to insert another sketch on my 6 o'clock datum, use centroid defined by plane, confirm the operation, show target, right click, paste, base point is the origin. Okay, we've copied in our sketch. Okay, now bear in mind when you do copy a sketch, sometimes some of our constraints are not copied through with it. Okay, and I think this is an issue that will be solved in a later version of ZW, but for now just bear in mind that sometimes when you copy your sketches across you may have some unlinking issues, so just play around with the design. We're going to have to make modifications to our dimensions anyway, and then we can add in the missing constraints. So let's try and modify this value first. We'll drop it down. Okay, so far it seems to be well linked up within the sketch, it's just that our sketch is not linked up to our origin. Okay, so let's add a constraint. We'll add a point coincident constraint, our origin, and the endpoint of this reference line. Okay, now let's give this a value. We're going to drop this down for the lower half of our ring shank. Let's say 1mm. We'll reduce our comfort fit as well. We want to drop it down to 0.25. Okay, I can see another unlink issue here. Our arc is not linked up to the end point of this curve. We can come in and use a point to line constraint. Pick the curve as our arc, and the point. Okay, if we pick the origin, we can pick the origin from the bottom here. Okay, now notice that we can either pick the origin as the point or the end point of our reference line as the point. Okay, so notice the number, the point is different for the origin. It was 4092, end point of the line 4104. So make sure that you're picking the right point. In this case, either of the points we pick will be just fine. Okay, so let's link that back up. Let's reduce our top width down to a 4, our bottom width to an 8. Let's say this length 1.25. Reduce our sidewall height 0.25. Okay, and our angle will drop down to 10. Okay, now notice that these dimensions are clearly not linked up to their opposite counterparts, so we'll have to link these up as well. They were lost during the copy. Right click, modify, link them up. Okay, so here is the bottom sketch. And that looks good to me now. I'm going to exit back out into our part level and we'll come in with a drive curve loft. Our driving curve we'll pick as the curve list of our template. Our profiles, our two sketches. Picking at the same point. Okay, we want no end caps and we'll keep the curves. Confirm the operation. Okay, so that is our drive curve loft for our ring shank, and if you look closely you can see that we're having some issues with our loft here. Okay, so even though our ring shank sketches are the same profiles, because they're slightly more complicated, we're having issues with the loft. Okay, so this means we need to come in with the connection lines to help our loft along. Okay, so I'm going to come in and add some connection lines. So let's start off with the main connection lines. Let's do the 4 corners to the 4 corners. Okay, these are all coming in correctly. Okay, the issue I believe will be with our corner inside here. Left click to place one here, left click on the opposite side. Let's see where they're linked up to. Coming down to the bottom sketch. Okay, so these are linked up fine as well. Our connection lines have come in well, and they seem to have sorted out our issue within here. Okay, if we did need to change the position, we can always use our modify to modify the position. Okay, if they weren't connecting to the right vertices, but in this case they seem to have done a good job. Okay, I don't think we need to add any more in. Let's confirm the operation. Okay, now shank looks good there. Save our work. Okay, so now we want to create our pave on this concave surface. We do not want it to come all the way around our ring, so we'll separate our face to create the surface to pave on. So I'm going to right click, insert a sketch on our side datum plane. Now I will reference the inside edge of our concave channel on both sides. Okay, using our top method. Then I'll come in to the face reference and reference the concave face. Okay, so we get the top reference line and the lower one. Let's exit out, show target, plane view. Okay, now we can come in with a simple sketch that we'll use to separate our surface. I'm going to place a line from here. I'll set this to be construction geometry. I'm going to come in with another 2-point line, horizontal. I'll set it to be construction geometry. Let's add a constraint, right click, add constraint. I'm going to constrain it, the midpoint, to the end of this line, midpoint constraint. Okay, next I want to constrain the end to be lying on this curve, our reference curve. To do this, I can use again my constraints. I'll pick the curve and then I'll pick the point. Okay, we're using our curve to point constraint, confirm the operation. Okay, so now this line will stay linked up to our curve, therefore staying linked up to the edge of our concave surface, no matter if we change the dimensions of our concave surface. Let's come in with a dimension here. Okay, you can see as we're increasing this value, our top line is staying connected to our reference curves. Okay, finally I'll come in with the arc that we'll be using to split our surface. Let it snap to the endpoint, or I can even change my pick to critical, so it snaps in at the endpoints only and the midpoints. Here is our arc. Let's delete the dimension, we don't need it. The radial dimension. Exit back out into our part level. Here there is our sketch. I'm now going to use a projection and a split. Okay, we will split with curves. This face. Remember, pick it as a face, not as a shape. The curves is our sketch. And we want a bidirectional projection along the x-axis. Okay, so it will be projected onto the surface and then we'll split along that surface. Okay, I do not want to keep the curves. Confirm the operation. 1 split, 2 splits. Okay, so we have 2 faces. Okay, so we're going to pave this top surface with our springs between 2 curves pave command. Then we'll add a pave around here, the gems between 2 curves command. Okay, first of all I'm going to add a channel in here for our gems to sit in. Okay, so let's first split these faces. I'm not going to use a curved split like in here, I'm just going to use a straight split. We can use our split with faces command. We're picking the 2 faces we want to split. The splitting face is going to be our top datum plane. Confirm the operation. We have a split. Okay, we're going to be adding in a channel here to place our gemstones in, so let's do that. We'll perform a face offset to duplicate this face. Offset of 0, and we'll change the color. Let's change it to pink. Confirm the operation. Okay, let's blank out our ring shank. Here's our new surface. We're going to come to the shape. We'll use our shell command. Pick the face. We want to shell it negative 0.3. Okay, so this will be the channel depth. Confirm the operation. Okay, we have created a 3-dimensional shape here. Let's perform a face offset to our top face so that we can get a good combine and remove without coincident faces. Let's just increase this, increase it to any number. Okay, and we'll also perform face offsets to our side faces. Okay, we don't want a positive offset, we'll change this to a negative offset. We'll drop it in 0.15 millimeters. Again, then we're going to add in a chamfer on these lower edges so that we form a bright cut when we combine remove to create our channel. Let's give our setback a realistic number. In fact, I'll just set it to be 0.3, the depth of our channel. Chamfer the edges, confirm the operation. I will now mirror this across, this whole shape across our front datum plane. Okay, and then I need to perform a combine remove of these shapes on our ring shank to form the channel. Okay, now what I could have done during the mirror, I right click, redefine. Okay, in the mirror I can come in with a boolean. Okay, there is the boolean option within our mirror command, so I can do it straight off in our mirror command. Okay, so we perform the boolean remove within the mirror at the same time as mirroring. Save the work. Okay, now let's check our edges before we do our pavés. Our edges are split up, so we need to come in with some curves from edge, which we can then concatenate so that we can perform our pave commands. Okay, I'm just going to do one channel side because I will be mirroring across. Confirm the operation. Okay, I could have changed these line colors to say green so I can see them better. Let's concatenate. So we can concatenate these two curves. Again, I could have changed my line color. Okay, so we have one curve. Let's repeat the operation. Another curve there. Okay, in the situation where they don't concatenate, then you can just add in a blend between your two curves and then concatenate them again, including the blend curve in the concatenate. Okay, but in this case they should be fine since our surfaces are tangent. Okay, so here we have our curves set up for our pavés. Okay, now before I perform my pavés and add in my prongs and cutters, I'm going to create some pierce work underneath our ring shank. Okay, and the reason I'm doing this now is because our gems and our prongs and our cutters, they all require quite a bit of computation time and memory. So a regeneration of my history will take longer after I've brought in my gems, settings, etc. So I usually like to leave those things till last of all in my design. Okay, so we'll come in with our gems, prongs and cutters after we've done our pierce work. Okay, so I want to effectively first of all shell the material from the inside of my ring shank. I want to remove material and then create some pierce work on the inside. Okay, so we could come in and try and use our shell command with an open face, let's say a thickness of -1 millimeter. Okay, and it fails, and the reason it fails is because our ring shank sketches are slightly more complicated. We can't shell, say, our wool here, this wool, because we'll be forming self-intersecting surfaces. Okay, I'm sure we could get away with a shell if we had a very small number, say -0.2 millimeters. Okay, our shell is working then. However, we cannot have our ring this thin. Okay, so we need to come in with a different strategy to shell out our ring shank. Okay, so what I'm going to do is first of all split up my ring shank. I only want to be removing material and adding piercework to the top of my ring shank. Okay, so I'm going to insert a sketch on my front plane. I'm going to create a sketch that I can use to split my ring shank up. Okay, and we've seen this done before, this method used before. Okay, so I'm going to set this to be construction geometry, add in some dimensions. Let's set this to be 20 millimeters. 20 millimeters. We'll have an angular constraint. Okay, and it's already going to be matching up the angle to the other side because we have this constraint here that came in as an auto constraint. Okay, so let's set this to be 80 degrees. Okay, I'm going to split my shank just below where our paves will come to. Exit back out into my part level. Okay, this time, instead of using my split with curves command, okay, I could use this to split the entire shape with the projection of my curves, okay, along the y-axis. Confirm the operation. Okay, and that will split the faces of my entire shape. Okay, but it will still remain one whole shape. Okay, but I want to split this up into two separate shapes. So I could redefine last and use my explode along curves option. This will explode along our splitting curves to create two separate shapes. However, I'll end up with no end caps, which I could come in and add with my end-sided face tool. However, I'm just going to come in, instead of dividing, splitting with curves, I'm going to extrude this sketch as a base, and then I'll simply divide my ring shank to this extruded shape, cap the trimmed regions. Okay, so this is the cap that we didn't get with our previous method. Don't want to keep the cutter, confirm the operation. Okay, so now we have our two shapes. Okay, and they have our end caps on there. Okay, so the way I'm going to remove material from the inside of my ring shank is by creating two more ring shank sketches and performing a revolve cut. Okay, so I'll start off doing that by blanking both parts of my ring shank. Okay, I have my ring shank sketches here, which I'll be using to create my new sketches that I'll be revolving. So let's insert a sketch on the 12 o'clock datum, use central define by plane. Okay, I'm going to right click reference. I'll reference this top line. Okay, we need to change our method to curve. I'll reference this top curve, bottom curve, and our side curves. Confirm, show target. Okay, now I'm going to offset this curve 1 millimeter. I'm going to come in with a line. Set my snapping filter to default. Let it come in and snap to the midpoint here. Left click, and then I'll let it snap to our reference line. Left click. Okay, so I'm going to turn this into reference geometry by toggling the type. Right click dimension. I now have control over this arc from this dimension here. Next up, I'll create two more lines, 2-point lines, coming from our endpoints of the arc, letting the auto constrain it to be parallel to these edges. Let's drag it out to be around here. Confirm the operation. Do the same on the other side. get that parallel constraint in, and we'll also let our constraints come in for our endpoints here. Okay, so they'll stay at the same points. So when we come in with a dimension constraint for one of these sides, it will change both sides. Okay, so we'll drop this to say 5.5. Doesn't matter as long as it's coming out the bottom of this ring shank sketch. Okay, and finally we'll just add in a 2-point line between here to finish off our sketch. Okay, so we have a closed sketch here. Its depth controlled by this value. Okay, so this is the material that we'll be removing in here from our ring shank. Exit back out into our part level. Right click, insert sketch. We're going to do the same for the bottom sketch. Right click, reference. Show target. Offset the top arc. Okay, we'll offset it 0.75 millimeters here. Come in with our first line. Come in with our next lines with the parallel constraints. Construction, dimension. Leave it at 0.75. Dimension this length. Let's leave it at 3. Okay, that's not staying well linked up how we want it to be. So let's leave this at 3, and I'm also going to come in with it on this side as well. Or I'll just link it up to this dimension. Okay, we'll exit back out into our part level. Let's just check out that top sketch again, that we're not having the same issues with it. Show target. Appears to be okay. I'll come in with a dimension constraint anyway, just to make sure. Okay, you can see for some reason I can't get my right clicking options. It's like I'm stuck inside of an operation. Okay, to cancel out of the operation I can use the escape key. Okay, now let's right click, unblank all to bring back the ring shank. Okay, I now want to perform a drive curve loft. My driving curve, picking it as the curve list. My sketches, these two sketches. It's going to come in as a base. Confirm the operation. Now let's perform a combine remove. Pick our base, pick our removing, if we set our option to remove. Again, this is why I split my ring shank up, so that our remove does not remove from the lower half. Okay, if I did not split my ring shank up, we would have material removed from all the way around our ring shank. Okay, which we may want. But in this case I'm going to add in some pierce work in here. Save our work. Okay, we can always come in to this sketch. We want to modify how far down or up that we are removing material. regenerate. Okay, like so. I'm going to undo that. Blank that sketch out. Let's also blank out our ring shank sketches. We've made use of them now. Okay, so next up we'll add our top and bottom ring shanks again. Okay, so we create one complete shank. Okay, it's not an issue that these faces are split up. Okay, if we hide our edges, you can see that it doesn't matter that we have edges there. Okay, so next up we're going to create a surface in here that we can unfold to the plane that we can then add our piercework to and subsequently refold it back in. So let's first of all come in with an n-sided shape. We're using edges, picking these edges, confirm the operation. There's our face. Let's unfold it to a plane. There's our unfolded. Okay, that looks good to me. Let's confirm the operation. Now let's insert a sketch. In fact, we won't insert a sketch, we'll come in with a pattern sketch. Pattern sketches. Pick one that we can use for our piercework. I'm going to use this first one. Left click to select it. We'll place it on the top datum plane, confirm the operation, and then going to double click to enter into that sketch environment. Let's blank the part level. Okay, so here's our sketch. I'm going to copy it in two directions so that we can fill up our unfolded face. Okay, so let's first of all copy from point to point in this direction. Confirm. Let's check that that will be enough to fill up. Yes, that looks to be wide enough. And then we'll copy vertically. From point to point. We'll make multiple copies of this. That gives us plenty of extra there. Confirm the operation. Okay, we'll come in and draw a box, a rectangle, corner to corner around our pattern so that we can position it exactly. Confirm. Let's show target, and we'll reference our unfolded face. Confirm, show target again, go into a plane view. Okay, now we'll use our inputting options to move our pattern into position exactly in the middle of our unfolded face. Come to move, the entities that we want to move. Okay, we'll window pick everything and then control unpick the reference curves. The from point, we want to pick the center of our pattern. The center will be around the center of one of these Okay, the center, from point, use our inputting options, right click between, right click middle of this line, and right click the middle of this line, 50% to get our center point. That's our from point, our 2 point, same method, between, middle, okay, of this line, or we could say this line, doesn't matter, between that point and the middle of the opposite edge. Okay, 50%, we'll get the center of our unfolded face, confirm the operation, confirm the move. Okay, we have moved our pattern and centered it exactly. Okay, next up we would delete our outside rectangle. Okay, and I'm just going to delete these other parts. It doesn't matter since we will be trimming them out to our unfolded face. Then I'll come in and trim away the excess edges. We'll use our edit, drop down, geometry, intersect regions. Our first region is our unfolded face. Second region, auto pick everything, and I want to auto close the region. Let's confirm the operation. Okay, so that seems to have gone well. Let's come in and tidy up certain parts. Okay, if it's very small like this is a tiny amount that we would be piercing out, so it's pretty pointless. Let's just delete it. Okay, so we'll delete our smaller pierce work to ensure that we get a clean job after the fact. Okay, so delete out the tiny bits. The rest of this looks okay. Let's inquire distance. It's less than 0.3. There's not much point in it. Let's delete. Okay, the rest is looking alright. Let's take away these small pierce work as well. Inquire. I'll leave that, we'll just get away with it. Okay, let's exit back out into our part level. Okay, first of all we need to ensure that we have a closed sketches here, we have no open edges. Okay, let's exit back out into our part level now. We will now create the pierce work that we will refold to the inside. Okay, so we first of all will extrude, insert curve list. We're going to extrude our unfolded face to create a shape that we can pierce through. Extrude it one side. Let's extrude it a distance of 0.5 millimeters. We want to add the end caps, confirm the operation. Now let's extrude cut our lower sketch. Let's do a symmetrical extrusion. Let's say 1 millimeter is enough. Remove from this shape. Confirm the operation. Okay, that looks pretty tidy. We can now wrap two faces, wrap by refolding an unfolded feature. The geometry is this pierce work, the source is our unfolded face. You can see it thrown in there, confirm the operation. Okay, now we can delete that face that we created and unfolded. Left click, delete, there is our pierce work. Okay, we have a little excess thing here, let's just erase that. And we'll erase the unfolded curves as well. Save our work. Okay, next up we will be paveing our surfaces, coming in with the prongs and then the cutters.